A flower once grown mainly for beauty helped Ukraine build an industry powerful enough to shake the global cooking oil market. In the late 1990s, sunflower fields stretched to the horizon, and millions of tons of seeds were harvested. Yet nearby, many oil plants stood idle, some running at only 30 to 40% of capacity. Ukraine carried the risks of farming, while much of the profit left the country with raw seed exports. This happened as the post-Soviet economy collapsed. Hyperinflation wiped out savings, farmers lacked money, machinery deteriorated, and millions fell into poverty. Then Ukraine changed the game. By 2021, it produced about 1/3 of the world's sunflower oil, supplied nearly half of global exports, and earned around $6.4 billion. How did an ordinary flower create such power? Let's find out with Mandarin Tech. The journey of the sunflower did not begin in Ukraine's black soil fields, but more than 8,000 kilometers away in the wilderness of North America. There, indigenous peoples soon discovered the hidden value behind its yellow petals. For around 3,000 years, they carefully selected plants with larger flower heads, fewer branches, and seeds that did not easily fall when ripe. Over generations, the tiny seeds gradually grew to nearly 10 times the size of their wild ancestors. They became food that could be eaten raw, roasted, ground into flour, or pressed for oil using simple tools. In the 16th century, Spanish explorers carried sunflower seeds across the Atlantic to Europe. Although indigenous peoples in North America had long used the seeds as food and pressed them for oil, Europeans were more interested in the plant's bright appearance. As a result, sunflowers were mainly grown in noble gardens and botanical research centers rather than on large commercial farms. While Europe was still admiring the flowers, their greatest value remained hidden inside the black shells. Only when the sunflower reached Russia did the door to a huge industry truly begin to open. During fasting periods in the Russian Orthodox Church, many common foods and fats were restricted, while sunflower oil remained an acceptable choice. This demand pulled the flower out of decorative gardens and onto large production fields. Sunflower oil production was recorded in Russia as early as 1769. By around 1830, it began to be commercialized, and the growing area quickly exceeded 2 million acres. As the supply of seeds increased, more oil mills appeared, using crushing, heating, and mechanical pressing. But as production expanded, the weaknesses of older varieties became clearer. Low oil content, uneven ripening, and difficulty being harvested by machines on a large scale. In the 20th century, Russian breeders began changing the structure of the plant itself. One of the most important figures was Vasily Pustovoit, who worked with his team to select plants with stronger stems, uniform flower heads, larger kernels, thinner shells, better disease resistance, and higher oil content. Over many generations, the sunflower gradually became a biological oil factory, with some varieties reaching nearly 50% oil content. By increasing the oil content from 35% to 45%, 1 million tons of seeds could theoretically contain about 100,000 additional tons of oil. Russia created the market and improved the seeds, but in Ukraine, that potential was about to face an even harsher test. When high-oil sunflower varieties reached Ukraine, they entered an agricultural system close to collapse. The country had vast Chernozem plains rich in humus, among the world's most fertile soils, yet farmers could barely use that advantage. After the Soviet Union fell, old markets and supply chains disappeared. Hyperinflation exceeded 4,700% in 1993, wiping out savings, while farmers lacked money for seeds, fertilizer, fuel, and machinery repairs. During this crisis, sunflower became a vital cash crop. Its seeds were easy to store, demand remained steady, and its deep roots helped the plant survive dry periods. But fertile soil alone could not guarantee high output. In 2001, Ukraine produced only about 1.1 tons per hectare, less than half France's yield of 2.4 tons. To improve both harvests and oil production, farmers had to rebuild the process from the ground up. Crop remains were chopped, compacted soil was loosened, nutrients were restored, and sunflower was rotated with other crops to reduce disease. High-oil seeds were treated against fungi and planted by machine at the correct depth and spacing. From germination to flowering, every stage required protection from weeds, pests, disease, and drought. The flowering period was especially critical because it determined seed weight and how much oil each seed could store. The season's result was not truly decided until the last flower heads bent down and the seeds turned black. Harvesting too early left the seeds wet, requiring more fuel for drying and increasing the risk of heat and mold in storage. But waiting only a few days too long could allow wind, rain, and birds to reduce the crop. Combine harvesters therefore entered the fields only at the right level of maturity, pulling in the dry flower heads, separating the seeds, and loading them directly onto trucks moving alongside. After leaving the fields, the seeds faced two possible paths. For farmers who urgently needed money for fuel, supplies, and loans, selling to foreign traders was the fastest choice. In the 1998-1999 season, around 40% of Ukraine's sunflower seeds were exported as raw material, while many domestic factories operated at only 40% of capacity. Ukraine carried the farming risks, while the value from pressing and processing was created elsewhere. In 1999, the government introduced a 23% export tax to keep more seeds inside the country. 2 years later, the tax was reduced to 17%, but tax loopholes were tightened. More trucks began heading to domestic processing plants instead of the border. With a stable supply of seeds, factory capacity rose to 70%. Ukraine had kept the seeds, but to keep the profits, it still had to release the oil trapped inside their black shells. A truck fully loaded with sunflower seeds has just left a Ukrainian field, but it still cannot unload directly into the oil processing line. At the factory gate, every shipment must first pass an inspection. Automatic sensors measure moisture levels, while technicians collect samples from several parts of the truck to check the color, the percentage of broken seeds, signs of mold, and the amount of foreign material. After passing inspection, the truck moves to the receiving area and opens its discharge gate. A stream of shiny black seeds pours into large hoppers before conveyors, bucket elevators, or enclosed pipes carry them into large silos. Inside, temperature and moisture are monitored, while forced air ventilation prevents hot spots, mold, and self-heating. The silo is therefore more than just a storage facility. After leaving the silo, the seeds enter a multi-stage cleaning process. Vibrating screens use different layers of mesh to remove straw, dry branches, stones, and soil. At the same time, high-pressure airflow carries away dust, dry leaves, empty shells, and lighter undeveloped seeds. On some production lines, magnets also capture metal fragments that could wear down or damage the machinery. Only clean and undamaged seeds are allowed to continue. The most valuable part is still hidden beneath the black shell, so the seeds are fed into a centrifugal dehulling machine. Its rotor can spin at up to 3,000 revolutions per minute, creating enough impact to crack the shells without crushing the kernels. Thanks to precisely designed guide channels, some machines can process more than 1,500 kilograms of seeds per hour. The mixture of kernels and shells then passes through an air separation system. The airflow carries the lighter shells to one side, while the heavier kernels fall onto a conveyor. The shells are collected and turned into fuel pellets or burned in boilers to provide heat for the factory. The kernels then pass through an optical sorting machine with a capacity of about 3.5 tons per hour. Light sensors detect discolored or damaged seeds, pests, and foreign objects, while compressed air removes them from the flow of material. Even after cleaning and dehulling, the sunflower kernels are still not ready for pressing. The oil remains trapped inside millions of tiny cells, so the kernels must be treated with steam in a screw cooker or a vertical conditioning chamber. The temperature usually ranges from 100 to 120 degrees Celsius, depending on the design of the production line. The goal is not to cook the kernels as food, but to soften their tissue, reduce the oil's thickness, and partially break down the cell walls. Only when the correct temperature and moisture level are reached can the oil be released efficiently under the pressure of the screw press. Once the correct temperature and moisture level are reached, the kernels are sent to the screw press, the heart of the production line. Inside a long steel chamber, a screw rotates continuously, pushing the material through a space that becomes gradually narrower. The rising pressure forces the oil out of the cells, through small openings in the press chamber, and into the collection system below. The first oil is usually dark yellow and still contains fine particles, while the solid material is pushed out at the end of the machine as a dense press cake. The press cake still contains a certain amount of oil. So many factories press it a second time to recover more. On a large scale, even a few percent of oil left behind can equal thousands of tons of product each year. The final cake is drier but still rich in protein, fiber, and minerals. It is crushed, cooled, or formed into pellets for animal feed, while some of it can also be used as organic fertilizer. Sunflower oil coming directly from the press still cannot be poured into bottles. Although most of the large solid particles have already been separated, the oil still contains countless fine sediments, cell fragments, and tiny impurities that cannot be seen with the naked eye. If they are not removed, the oil may lose its color more quickly, develop changes in taste and smell, and become less stable during storage. To meet the strict standards of the food industry, the oil must continue into the refining area. Here, phospholipids are gathered together and removed during the degumming process. Free fatty acids are then neutralized before the oil goes through bleaching to remove pigments and unwanted compounds. Finally, steam is passed through the oil under controlled conditions to carry away volatile substances that cause unwanted odors. Step by step, the original dark yellow oil becomes lighter in color, milder in smell, and more stable during storage. However, not a single drop is allowed to enter the bottling line before passing laboratory tests. Samples from every batch are tested for moisture, acidity, color, and smell. Only batches that meet all required standards are allowed to leave the laboratory and enter the fully automated bottling line. Empty bottles are rinsed, dried, and moved to the filling unit. A dosing system controls each nozzle, ensuring that every bottle receives the correct amount of oil. Depending on the size of the factory, the line can process between 3,000 and 10,000 bottles per hour, with common bottle sizes ranging from about 250 milliliters to 2 liters. Immediately after filling, an automatic capping machine places and tightens each cap within seconds. The bottles then pass through a sensor-controlled labeling system before the production date, expiry date, and batch code are printed. Automatic cameras detect underfilled bottles, loose caps, or incorrect labels and remove them from the conveyor before packing. At the end of the line, the packaging system places between 6 and 12 bottles into each box, depending on bottle size. The boxes are sealed, printed with traceability codes, stacked onto pallets, and wrapped in plastic film to keep them stable during transport. The finished pallets are then moved into dry storage or temperature-controlled areas where they wait to be distributed to supermarkets, shops, food factories, and international customers. But not every sunflower seed harvested in Ukraine is crushed for oil. Large seeds with intact shells and firm kernels are separated from the industrial flow and sold as a valuable snack product. First, the whole seeds pass through screens and optical sorters to remove empty, cracked, discolored seeds and foreign objects. Depending on the machine and impurity level, optical sorters can process about 300 kilograms to 10 tons per hour. Approved seeds are then weighed and packed into 50, 100-gram bags or larger packages weighing several kilograms. Modern seed and nut packaging lines can reach speeds of up to 200 bags per minute. Each bag is sealed immediately to keep out moisture and preserve freshness and crunchiness. Some seeds are processed into sunflower kernels. They enter a dehulling machine where controlled impact cracks the shells without crushing the kernels. Some commercial machines can process about 500 kilograms per hour and remove nearly 95% of the shells, depending on seed quality. The mixture then passes through a strong airflow. The lighter shells are blown aside, while the heavier white kernels fall onto a conveyor for final inspection. After weighing and sealing, they are delivered to supermarkets, bakeries, and food factories. Ukraine's sunflower strength is not defined only by how much oil it produces, but by how quickly it can move that oil to global markets. And the Black Sea is the key. From its southern ports, Ukrainian sunflower oil reaches Europe, the Middle East, North Africa, and Asia. Before the full-scale war, Russia and Ukraine together accounted for about 77% of global sunflower oil exports and 79% of sunflower meal trade. When ports were blocked and factories reduced output, the shock quickly spread to supermarkets and food producers thousands of kilometers away. The war also changed how sunflower seeds were used. In 2021-22, weaker crushing capacity forced Ukraine to export more raw seeds. By 2023-24, processing had partly recovered. The country crushed about 11.6 million tons of seeds, produced nearly 5 million tons of oil, and exported around 4.5 million tons. Raw seed exports fell as more material was processed at home. Ukraine's sunflower story is not only about agriculture. It shows how an ordinary industry can become a strategic strength, yet remain highly vulnerable to war and global disruption. When supply chains break, trade routes built over decades may have to be redrawn. Do you think Ukraine can regain its leading position? Or is a new order in the sunflower oil industry beginning to take shape? Like this video and follow Mandarin Tech to keep exploring the industries quietly shaping our world.